Howdy, folks. So this lesson is going to be geared towards a fundamentals in modeling. I find a lot of the time, and especially a lot of the people I've spoken to as well, when they've gone to school for 3D, they've often been told like no tries, no tries, no tries, but like they're not really explained how to not do tries. Like obviously you need to connect another loop to it, but like there's a lot more going on in terms of like what makes up a mesh. And I would think about a lot, like my analogy for it is if you think about like Sudoku, where everything does fit in a certain way, and if you're following the rules of the game, it fits together really well. And there is, certain rules to follow that if you do, it's technically considered correct or not. So, and it's, kind of a procedural in that way. It's sort of like a procedural puzzle. So I'm just going to explain like how I think about it, my terminology for it. A lot of these terms I just make up. So if you see somebody else using different terms, that's valid. This is just how I think about it. So to start, I'm just going to describe the different types of points in your mesh. So when I say points, it's interchangeable with the word verts. It means the same thing. So if I go into edit mode here, I've highlighted all the anchor points in red. And what the anchor points are is they define the overall shape of your model. So they are the points where if you move them, you will start to drastically change the shape of your model. They're points where you probably wouldn't be able to smooth them without changing the shape. So if you think about like a face, these would be the points that form the eyelid, the points that run around the nose, the points that like make up the mouth, all the things that like define the major details of what your mesh is. And knowing this is very important because getting these points in place first before other ones and pushing patterns into the other areas, like the floating points, is going to be really critical to building up a mesh like easily without getting swamped with topology or getting like overrun by it. So that's what anchor points are. Bridge points are kind of, actually, hang on, let me explain floating points first because bridge points are in a way sort of a hybrid of the two. So floating points are sort of the opposite. They are the vertices in the middle of flat spaces. So these could be like the backs of chairs, the backs of picture frames, like the flat nondescript part of your objects. So spaces like that can be filled with any amount of topology to gain that shape, whereas like anchor point spaces are typically like you do want a specific amount of verts and verts in specific places in order to get the shape to work. So floating point values should always be dictated by how heavy your anchor points are. And then bridge points are basically kind of halfway in between. So I have highlighted, like, I haven't highlighted everything on this model. I kind of stopped around like this point. But if I move around, you can kind of see what I'm talking about. So bridge points are kind of a combination of the two, where in one row on their own, it's not enough to define like the shape of the object, but putting them together does. So even though there's no like specific anchor point like controlling the shape of this branch, if I were to like smooth these out, it would fundamentally change the shape. So that's kind of how I think about it. And the reason why this is important is in relation to patterns. So patterns are how you redirect geometry and join like different angles of axes and stuff like that, and how basically you fuse different shapes together. Um, and the reason why it's important is because of how it will affect surfacing and how it will affect lighting. So the way it will affect surfacing is you don't want these different points to turn into different things. So like say for example, if I'm using this edge here as an anchor point, and then I have it transition into being like a holding edge for this anchor point, then if surfacing wants to cut a line down there, they won't be able to. And the same way that you don't want to put patterns next to your anchor points because since it's typically like more defined, there's typically like a stronger angle on either side of the anchor point. If you put patterns in those areas, it's going to show up in the lighting. So basically what you want to do is try to push patterns inwards towards the floating points. You can have a few on the bridge points, but you have to just be careful about how they're used and not have too many. So that's just a basic breakdown of the different vertices. Moving on to explain patterns more. Okay, so if I go to the top here, when I say grid or no pattern, I just mean it's an equal number of values going in either direction. And then I actually don't consider a star a pattern because a star is just three different axes coming together into a point, which is why they're kind of notoriously difficult to move because in order to move a star, so say we have like these ones here all coming together. And the reason why they work is because when you want a mesh to be quadded, you need to have an even number, and a star is uneven on two levels. So we have like 3 loops or 5 loops, sorry, connecting at this one point, and then each of those 5 loops is divided among 3 axes. So then 5 plus 3 makes it even. So that's why, even though this is a star shape, it's still all quadded. And the way to move a star is like you would literally just have to increase the number of loops. So like I would have to add more loops on this side if I want to push it in this direction or what have you. So it's more just about shifting where the defining like loops of those axes are starting, and that's how you would move them around. So in terms of like actual patterns, I basically consider there to be like 2 different types of pattern families, so to speak. I would say there's clips and there's redirects. So a clip is meant to solve an irregular number in the same axis. So either you have too many up here and just one down here, or like whatever it is, but it has to be along one axis, not, and even if it's diagonal, it just has to be along one of them. And then a redirect is like a combination of more than one. So essentially just the shapes you get will be a little bit different. That's why that's, of importance. So I have these basic ones here. The cyan blue line is marked as, say you have your grid, like this would come from a grid that would look like this, you just have your grid, but then you have 2 extra edges running down. So like how do you get rid of them? So the magenta line is basically the clip that's happening. So they're forming together, and then you're deleting this middle edge to create like this flag shape. So this is a really basic one. That's like one of the ones most people know, it's standard. And then there's like a hard turn and a soft turn. So the main difference between these two, again, if I draw this little gritty. Okay, so you have your extra edge coming down this way, and you have another edge you want to clip this way. It's basically just the difference between going in the left direction or going in the right direction. So if you go away from the edge that you're using to redirect, then you're going to get a hard turn. And if you go towards the edge that you're using to redirect, you're going to get a soft turn. And basically the only difference between these two is how it's smoothing on your model. Sometimes a hard turn is like you need to use it because of the surrounding topology. Sometimes you want to lean more towards soft turns because generally they smooth a little better. It honestly, it completely depends. Like if you're doing hard surface, like hard turns are completely fine, but if you're on an organic model, like I would suggest gearing more towards soft turns. And then complex patterns are just combinations of those things. So shield, for example, is formed by having essentially the same thing but more. So instead of having 2 loops coming down, what if you have 4 coming down? And then you're basically pushing these together, pulling this, oopsie, I don't have my, oh, I do have it on by distance. Pulling this up and then getting rid of this. And you're making this like diagonal shape. And the benefit of doing this kind of shape is it smooths very well in a like the floating point area of a model. It tends to give you, even though you are using a flag, it tends to give like a very nice smooth form. And then other versions of combo patterns, of course there's probably more than what I have here. I just kind of listed some like more common ones, but like if you have a hard U-turn, it's just 2 U-turns side by side. So like you have, say for example, this is used a lot on like necks, or like if you have a character's face and there's like a bunch of topology running down, you don't want to have like all of that topo running into the body a lot of the time. So like typically this will happen kind of like around the Adam's apple area of the face or the body, just because it kind of complements the shape that would be there already by the neck. So that's an example of where you'd want to use something like that. And then we have like some S turns here, which you might think, why don't you just have this loop go here? And then you don't even need to make a shape. But what if you have a form that's wrapping around this way, another form that's wrapping around this way, and you physically don't have the edge from this side to put there? So like sometimes it kind of depends, like on trees. A lot of the time you might get a pattern that's kind of like this. Is more common. Generally you won't really see this. And then I have like a heart here, and you might think, what's the difference between a heart and a shield? Because that's just gonna like smooth crappier than a shield would, which correct, it would, because now you have like these 2 points really close to each other, but they can go around an anchor edge. So if this is an anchor edge, you can reinforce on either side and just cut the heart in half, and you'll still be able to clip in the same spot. Whereas if you try to do that with a shield, you wouldn't be able to. So They're like similar but different. It depends on the shape of your model, where you're putting it, etc. And then we have a leaf here. Typically this is just used to add volume in an area. So like, especially like if your topology is doing, again, like I'm going to use trees as an example. If your topology is doing something like this and you have like one loop running through, you're probably going to want to add a few more just to like buff that area a little bit more, just to add more support. So that's some examples of like how patterns work. So that's the techniques you can use to redirect topology. But in terms of like the angle you should redirect, this is about axes. So if we look at, let's look at this top half first, because neutral axis and diagonal axis are terms I use a lot. When I talk about neutral axis, I'm talking specifically about the primary or secondary axis. So like the main XYZ up and down, left and right axis that you would be using, and this is context sensitive. And then the diagonal axis just means the off angle of that. And the reason why this matters is because a neutral axis is worth 1 and a diagonal axis is worth 2. And this is, I have an example here to explain kind of what I mean. So anything running along this axis, or this one, is worth 1. Anything going diagonal is worth 2. And okay, so say you have a corner here. This is something I see incredibly common with modelers. In order to reinforce that corner, you need to have loops on either side of it, of course. But then what ends up happening is you get all these loops running close together. And a lot of the times you don't really need that. So instead of running one loop in this direction and one loop in this direction, because each one has a value of 1, we are going to run it diagonally in this direction. So we only need to run one loop that's worth a value of 2. So if I go in that direction, that allows me to get rid of these two without having to like run them anywhere. So now I have one less loop to worry about. And I could do that one more time if you needed to, by pushing into the diagonal one extra time. So going diagonal one more time, getting rid of 1 and 2. So it's still quadded, it's still reinforced in this corner, but now we're not getting those extra loops that could potentially cause like shapes that we don't want to see in other areas. So you just want to have good mesh control to make sure that your anchor edges, your holding edges, are following those correct axes. And just to quickly explain the difference between, because sometimes I'll say like buffer edge and sometimes I'll say holding edge. And they are very, very similar, but they're slightly different. So for example, if I make a cube and I make some edges here, if my intention is to subdivide this mesh, then these would be holding edges, and they're basically helping to control the shape of the model in that subdivided state, right? Like everybody knows that. That's pretty basic. But a lot of the time, buffer edges are neglected to be used in cases where, like for example, if we don't have this edge and we have a pattern over here, and it's going to contact directly with like this edge. So say for example, let's just make a clip really quick. So say we have this clip. Hang on. Let me just delete the back here so it's not running around. Okay, so say we have this clip here coming to a point. If we have this buffer edge, it's not going to interfere with the subdivision that's happening at this point, because it's going to be able to be uninterrupted moving that direction. So you can see it's still like pretty smooth and there's nothing like really obscuring it. Whereas if I get rid of that and I smooth, so now you can see there's kind of like a little bit of a dip happening in this gray area. And sometimes it can be pretty subtle, but other times it can be like kind of obvious, and there's nothing that surfacing or lighting can do to hide something like this. It's going to show no matter what. So we just have to be aware of like where we're putting those patterns, making sure we have a buffer edge. And another distinction too between buffer edges and holding edges is if a holding edge is kind of within this range, I consider it a holding edge, but a buffer edge could honestly be all the way down here. It doesn't really matter. The point, like the work of the buffer edge, is to keep the pattern away from the anchor edge. So it's more like when I say holding edge, I'm specifically talking about a close distance from the edge in order to get a sharp edge with smoothing. And then buffer edge is like just be aware of your patterns and what edges they're touching. So that's the distinction there. So neutral axis, diagonal axis, and there's one more term or two more terms for it, and then there's the primary and the secondary. So this is specific to the object. Your primary axis is informed by the world space and the object's rotation in that world space. So say for example this tree. its primary axis, because it's growing straight up, even though the shape is like this way and like some of it's this way, its orientation in world space is straight up. It's meant to be placed straight up and down. Whereas like say for example, if you have a cylinder, and let's just pretend this is like a bat or something. We'll pretend this is a bat, and it's rotated like this. Its primary axis would be off center because the object itself is rotated, because if it's neutral up and down, it's going to be like this, right? Whereas with this tree, this is its neutral axis, because if it wasn't, like, this tree isn't meant to be placed at any other rotation, right? It's meant to be placed like this. So that's basically what that means. It's informed by the object. So if the object is rotated in space, then your primary axis is rotated in space. But most of the time when you build things, you build it neutral. So like 99% of the time, your primary axis is going to relate to like your scene. So I just want to make that little distinction. And then the secondary axis is informed specifically by the details in your model, and it will change. Basically, the secondary axis can potentially change every time there's an anchor edge. So in this case, there is the anchor edge informing the shape of this model, and the secondary axis is like every shape change happening. So if I had like a clump like this or something, that secondary axis would be going this way. And the reason why this is important is because even though like I call this the primary axis and I call this the secondary axis, what's most important per each area of your model that you're like working on is actually the secondary axis. That should take priority over anything else. And the reason why I say that is because, again, if you take this tree, for example, if I were to use the primary axis, which is like, you can see it a little bit at the bottom here, if I were to use that all the way up, then I would start to get skewing. And then what's going to happen is I'm going to get a diagonal over the course of like where I shouldn't have one. Because diagonals you want to use strategically in order to like clip and reroute geometry. You don't want to use it to build. Primarily A, because it deforms very poorly. B, it makes surfacing jobs more difficult, but also it's just not as clean for topology. So you need to adapt the shape, like the axis that you're using, to like the shape of the object that you're building to. So you just have to make sure that you like stay following with that. And then you'll notice in spots like this, for example, well, this is a lot more spaced out and this is a lot tighter, so you would probably want to use clips so you don't have as many loops running in this direction. You may need to use redirect to connect different areas. You're probably going to have to use some leafs on this side in order to like add extra volume in topology where you need it here, and then remove it here, because the objective is to try and get the same roughly the same level of resolution across your model. And so like say for example in this tree, the average resolution is like roughly, I don't know, like roughly this square size. So if like most of the tree is following like roughly that size, then when I go to like clip edges together or reroute geometry, doing patterns becomes like significantly easier if it's all roughly the same size. And the size you go with is dictated by like the design of your model. So like in the case of a face, I would have the eyes, nose, and mouth dictate the resolution that I'm using for the face. You want to go with the most complicated parts, because like if you look at, for example, this, like the space down here, this could be done with that many loops, it could be done with this many loops, like it doesn't really matter, it's still going to read the same shape. But like this branch, for example, if I only have this many loops, like it's going to change the shape quite drastically. So that means that this size here becomes kind of like my base idea. And generally speaking, for most models, you want like your smallest faces and your biggest faces to be like within 50 to 100% size of your main one. So like on a tree like this, if I ended up having like really big faces down here, even though technically it still hits the shape, just because I have some smaller areas that go a lot smaller, it's more clean to add more. Again, because it helps with like patterns, it helps like quadding your geometry and stuff like that. So in terms of putting all that together, let's say it's like, so how do you actually quad geometry, right? So if we just take this tree, let's just start quadding a few spots. First thing, definitely, you want to have a mesh lint, because that's going to make it a million times easier to to find where your tries are and stuff like that. So you definitely want to try and merge. You want to focus on one area at a time. There's like quite a lot of problems with this tree, obviously, and like a bunch of areas are lighting up. So just to avoid distractions, I don't care about 6+ edge poles, like 90% of the time. If they're causing an issue with like subdivision and it's like creating pinching, then like for sure you should deal with it. But like most of the time, it's not a huge problem. Um, and I don't want to click non-manifold right now. You want to know just what the number is, but like I don't want to flag it just because it's going to flag like all these end pieces and stuff like that. So the reason why the number of non-manifold works is because in the beginning I was saying mesh needs to be even number, right? So I have 300 non-manifold elements. So that means I have an even number on my open edges. So what that means, if I'm going to add any topology in order to quad any tries in my model, if I add it to an open edge, I have to add at least 2, because if I only add 1, then no matter how I reroute the geometry in my model, it will never ever equal like fully quadded. And even if I like, because the worst case scenario that could happen with that is like, say I add an extra edge down here and I get rid of this point and I get all the way up here, and then you get to the top of your model and you think you could just add an extra edge up here to quad it off, and it works for that one try, but the problem is now you have an open edge with an odd number, which means you have to add or remove that odd number in order to make it even, which means you would need to add or remove the entire length of the tree to get all the way back down to the bottom to make the bottom even again. So it's just better to be like aware of the amount that you're working with, because that might dictate whether you add or remove and like where you send things. Okay, so I know my model is even, just going to keep that in mind, check that off. I don't need that right now either. And we'll just work with that for now. So we'll clear some like obvious ones first. Like generally speaking, it's better if you get the ones that are close together. So let's just continue that on. And I kind of have equal but opposite values can kind of come together. So if I do this, I can just bring them together. That wasn't really an example of that, but that's more of like an abstract thing I was just mentioning. If you do have two patterns, maybe I can find an example of it somewhere. Okay, so I have this is kind of an awkward spot. So actually, no, it's not, because there's a try up there. So let's just do that. And this is easier if I run it across. And there's another try right here. And now I am putting a pattern right on an anchor edge. That would be something that would be cleared. Like, for example, okay, so to explain a bit more, this tree is made for like a video game context, so I wouldn't really care about this, and I used an emission shader on it, so like this wouldn't show. But if you were in an animation context and this tree was meant to be used for like animation, you would definitely have a buffer edge to like clear that pattern. But if you know you're adding that later, then adding this pattern next to the edge is okay for now, just as long as like you're aware that you're going to change it. But this is purely just to show quadding techniques. That's not something that would be required in order to quad, because like I said before, you shouldn't mix edge types. So the edges you use to quad your geometry should primarily be like floating points and bridge points, not buffer edges. So in theory, you could fully quad a mesh and then reinforce all your edges after the fact. It's a little bit cleaner if you do it that way, because if you start to mix, like, again, if you start to mix edge types, it could get a little messy for surfacing. So that's a long-winded way to explain why I think that's okay, even though I just said it wasn't. Context is everything. And okay, we'll continue going down here. So this is an example of where the diagonal is starting to mix a little bit. If I look at other parts of the model to help me inform where that should go, there's this loop here and this one here, and that's like pretty neutral along this axis. So instead of running this down this way, which is probably a remnant from when I was building it, we're gonna like rework this way. And then I can kind of bring these guys together a little bit. And then I can just kill these. Now I do have an extra one still, which is fine. I'll just push that more towards the middle. I kind of call this like a tactical try. So this is very easy to add this way or add this way. Like I have a lot of choices for like how I want to reroute this, or I can put this up here. So when I have a try like this where it's not immediately obvious which direction I should put it in, you just leave it and then come back to it, because there might be a really obvious spot later on. Because like I could reroute this down here to get rid of this try, and I did briefly think about doing that, but once I get down here, I see it's actually a lot more smarter, I guess, to connect to that point, because otherwise this point doesn't really have a good spot. So we'll keep going, can keep highlighting. Stuff like this, again, is like pretty easy just to like quickly add an edge on either side. That's like a really fast way to get rid of them. We have two open edges here, so I'm going to add one, making my bottom uneven, and I'll add another one, so my bottom is still even. That's just something to be like mentally aware of. And then, okay, so I'm going to kind of ignore the ones on here because that's pretty obvious. You basically just, you have to add an edge going in this direction, because if I try to fix this try by going this way, I'm putting a pattern on an anchor edge. Again, you could create a buffer for it, and then, you know, add that, but it's a little bit cleaner, especially with these type of shapes, to just add an edge this way, especially since you probably want the hold going this way regardless, just because that would support the shape. And then we have more stuff like this. Sometimes, generally, if I'm not running edges, like for example, I want to be consistent with like how I lay my edges down. So I have an option here to run this up and just keep going this way. The reason why I'm not going to do that is because I haven't been doing that on, well, okay, other than this edge. Actually, you know what? It's fine. It's literally fine. Never mind. I go back on what I was about to say. It's fine. Change your mind because you're allowed. Okay, so we'll just keep going. Another thing here. You just keep going. Again, I'm going to kind of ignore these. Well, I guess I said I was going to ignore these, and then I'm promptly not ignoring these, but that's okay. Okay, so this one, it's a little thin in this area. It might be kind of nice to have that read, because then you could just kind of like puff that out a little bit. So if we just continue that over, that might be kind of nice. And then there's a try here anyway, so that works out. We're just going to push that further into the floating point space so that I can cut that across and do that. And then there's probably another try somewhere. Oh, right there. Yep, right there. That works. Oh, okay, wait, hang on. That's not the side I wanted to put it on, though. This side. That's the side I wanted. Yeah, okay. Now I have this other one. I don't want to clip it too close to this. I don't want to put too many patterns too close to each other. And honestly, I could just add it down here, because this is wide enough that it could merit another one. So we'll just shimmy that over. And grab that. But now keep in mind, my bottom is odd again. So actually, this might be a decent time to fix it. So let's run one loop here. And then just push this further into this area. More into the floating points. Whenever in doubt, just push it further into floating points, because that'll be a good way to keep your stuff off the edge. Do that. Do that. And then let's just kind of work this down this way. So the reason why I changed that direction is because I want to maintain that buffer edge that's kind of going around that way. And then when I add that extra edge down here, it's not really getting in the way of anything else. So it's like just a cleaner way to add that. So keep going. So how many? I have 43. It's an odd number. Keep that in mind. And it might be nice to kind of clip these together. So let's try and figure out a good way to do that. So if I run this here and make this kind of like part of this, get rid of this guy, put this here, run it this way for now, and then honestly putting that there, yep, that's probably the easiest way to do that. I'm just doing something like that, just modifying the shape slightly so that it's a little better. Now there is a bit of a shape happening on this anchor edge, but again, like if this was going to be for animation, you would reinforce on either side of all of these anchor edges, so it wouldn't be a problem. It would be okay. And boop boop, boop boop. Okay, so I'm probably not going to go too much further. I basically kind of cleaned up this whole bottom half. Let's just get rid of these two guys. And the thing is, you definitely want to keep, you know, you kind of want to work in sections and kind of like work your way up, because if you leave a try behind, it's not necessarily bad, but you're going to have to either add or remove in either direction. And like the more lonely, so to speak, that try is, like the further you're going to have to add or remove along your model to get rid of it. So it's just easier if you work together. This is still an odd number though. And I have two odds here. and I kind of want both of those odds, so I'll probably need to add another one down. So I want to change also the way this is coming together, because I'm not super crazy about it. Get rid of that. And then this could probably run, this would probably run across. And let's put this down here. Just kind of space out as you go, as you add to things. And then the easiest way to get rid of this guy is to probably push it into this side. So if I do this, that's probably the easiest way to go about it. And then I can just make this run a little bit further than it had been. And just do that. And even if you don't want to put, like, this actually isn't technically a bad spot for it, but even if I don't want to put that there, I can just run it a little bit further and have it be up here instead, because the benefit of that would be allowing more space to smooth this out. And then I also get kind of like a buffer between those edges. So, whoop. Just spots like this might be kind of tricky to smooth, but like, okay, here we go. Here's an example of equal but opposite. So we have a clip happening on this side, and we have a clip happening on this side, and one is going on this direction, and the other one is going in this direction. They are both equal but opposite in the same axis. So it's a similar pattern going the same way. We'll delete these, shift this up, put this here, put this here, and do that instead. So now I've taken that shape that was here and kind of shifted it over this way. And I've taken two patterns and combined them into one, and I can even push that a little bit further. I think I would like to do that. Let's see. Yeah. Here we go. So you can always kind of reroute patterns in like different orientations, and even when you do stuff like this, like if it's useful to have this separation, could keep it. Sometimes it's not. So now I had one clip running in this direction, I had one clip running in this direction, and now I have, instead of those two independent, I have one clip running in the opposite axis. So that's how you can kind of combine your patterns to reduce the amount that you're using. Again, it all comes down to like that simple math. Like if you have a redirect coming from one axis, you need one redirect coming from this axis. Remembering that diagonal is worth 2. So it's kind of, that's kind of what I mean earlier when I was saying it's kind of like Sudoku, where you're really just putting like 1s and 2s together in a way that like looks visually appealing. So that's how you would go about quadding things. Again, I lied. 1 second. There we go. Okay, there we go. Now I've quadded this whole bottom part, and then this bottom is odd. So, you'd want to add something, kind of look for like where a strategic point would be. Okay, yeah, so right here, this would probably be the most strategic, because that's a very little easy spot to add it to. And then we have the one that's, now this is even, all those extra points are even. If you're not sure, you can always just make sure. 308, so that's all even. So now all the remaining tries are within the mesh itself. I don't need to run it to the edge. So as long as you know whether or not you need to run it to the edge or within the mesh itself, that can make it a lot easier. And tries go together. N-gons, of course, is going to depend on like the value of the n-gon, but even if you like quickly clip off all the n-gons that you have, like even if you don't look at tries first and you just look at the n-gons and you quickly like if something like this is overwhelming and you just like quickly cap these off, you might already start to see spots where you can combine them. Like for example, I can just go this way, get rid of that, get rid of those first. Like even if you just do this and you don't do anything else with it, what this means, hang on, let me just do a couple. I'm kind of talking and doing this at the same time. Okay, anyway, so even if we're not looking at n-gons, we're looking at tries. So I have 124 tries, which is in line because my edge count is even, so my try count should also be even. So that means I need to like combine those together. So it's like, and then it's literally as simple as just combining tries. 2 tries go together and then they become a quad. So you would just repeat the process for the whole tree, and that is how you quad things. Let's just quick summary on all those things. Anchor point controls the shape of your mesh. Figure those out first before you figure out the other things. Push your patterns into the floating points so they're easier to get rid of, easier to combine, and easier to smooth. Here's the different patterns that you could use. Don't think of the star as a pattern. Think of it as the amount, like the axis that you need to like shift over. So you need to add or remove loops in order to move it around. And yeah, clips are for the same axis. Redirects are for combining two different axes. So if you're not sure what patterns you might be using, just keep in mind what direction those edges are coming from, and that will kind of dictate what your pattern should look like. And just keep in mind that the primary axis is dictated by your object and its orientation in the world space. Secondary axis is defined by specific traits of your model and is more important to follow than the primary axis. Primary axis gives you like a fundamental information of how your loops should go, but secondary axis is definitely what your final topology is going to end up looking like. And neutral axis is worth 1, diagonal axis is worth 2 when you are trying to triangulate. And please do your edges like this because it is much cleaner and surfacing will like you. Thank you, folks. That is all. Have a good day, like and subscribe, and goodbye.